Hello everyone. First off, I'd like to apologize a little bit about the quality of the PowerPoint I'm about to show you. It's a really old one. I don't have my typical animations, and it is an awful lot of text. What's important when we go through is that we need to identify some of the keywords, but there's really only four things I want you to get out of this, and I'm going to be very obvious about it when we get to it. Some of this should be a review. So let's get started. We're going to talk about types of chemical reactions. So we know what a chemical change is. We've done that before, and it's when you take matter and you mix up how the elements are bound together. Right? So you split in some of those ionic compounds, or you're breaking apart some of the molecular bonds, and you're rearranging how the elements are. Now, you have the same elements at the beginning and the end, but what you've done is changed who or what they're attached to. Okay? So we're changing a substance. Now, what's also involved in a chemical reaction is we're either going to gain or lose energy. Now, you typically think of a reaction as gaining energy, but actually there's some where you lose energy. And energy typically being in the form of heat. So most inorganic reactions, so inorganic meaning things that are not alive, okay, so we're not talking about cell splitting or things like these. We're talking about things involving non-organic compounds. Okay, they're typically in four types, and it's these four types of reactions that I want you to know about. So the first one, we call it a synthesis reaction. So the word synthesis means to create. So in a synthesis, what we're doing is we're combining two substances, and at the end we end up with one substance. So we're creating a new substance. Okay, and you're going to see these words, reactants and products and all that good stuff, which we'll get into in our next video when we talk about word equations. Okay, but what you got to know is we take two things and we create one. So let's take a bit of an example here. We have a skinny bird and we have a worm. The skinny bird eats the worm and becomes a nice plump fat bird. We've now taken those two things on the left, the skinny bird and the worm, and created the big worm on the right. Now, we have the same stuff, we've just transformed what it is. So it's a reaction, right? And that's where you need to go. Elements combine to make one compound. And that is the generic formula for a synthesis reaction. A plus B creates AB. Now, if you're taking notes, this might be a very good thing to take down. Just go synthesis, elements combine to make a compound, and then A plus B gives you AB. You don't have to draw the photo. Now there is going to be an example for this. So an example would be, we have hydrogen gas, we have oxygen gas. We make water. So the equation would look something like this. Hydrogen gas plus oxygen gas gives us water. So this is what we call a word equation. Then we can go into a symbol equation, which is H2O plus O2. And we have this little funny arrow here. So plus means that we're combining. And the arrow means it turns into. Now you notice the arrow is always going to point to the right. In chemistry, we always put what we're combining or mixing together. This is reaction. And this is going to be the product. So these combine, they react to create this, okay? So H2O and O2 react or combine to create H2O. And that's all it is. So you might want to copy this into your notes as well, the hydrogen gas, oxygen gas, like these two statements. But you're going to have lots of work on that later. So if you don't, no big deal. Just make sure you get this in here. So that's the first thing, a synthesis. We are creating, we're synthesizing. Okay, so the next one is a decomposition. In a decomposition, we take a more complex substance and we break it down into multiple parts. So it could be one substance that we create three substances out of, for example. It's basically a synthesis reaction, but backwards. So I'll show you a picture. So this is the second thing I want you to notice, but decompositions. So to decompose. So we have an egg. The egg reacts, right? I'm using air quotes on my fingers right now. You can't see it, but they're there. And it reacts to create a empty shell and a turtle. Okay? So we had one thing, now we got two. So let's the opposite of synthesis, but you notice how we don't just flip the arrow, right? We still have the beginning on the left, and then the arrow, and then the stuff on the right. Make sure you always do that. You have to always do that. Okay. The genetic formula is AB gives you A plus B. Now, I don't know why this arrow's up here. Again, old PowerPoint. I think this PowerPoint was maybe created 10, 12 years ago, so pretty old. At any rate, make sure you copy this down. That's what you want to copy down, this stuff up here. Okay. Again, you can pause if you need to. So an example of a decomposition. Well, we'll just take the same example. You can have water, and what you actually do with water is you apply a little bit of electricity to it. Okay, it's called electrolysis. And again, I wish we were in class. This is something we would do, and then we'd blow up the gases after and, have a good time. But nonetheless, maybe if it's next year and you ever want to see me do it, come by and say hi, and we'll pull it out one day at lunch and have some fun. But at any rate, you have water, it breaks down to hydrogen gas and oxygen gas, and the chemical reaction looks something like this. Water, now with the arrow, because it's going to decompose, react, right, turns into hydrogen gas and oxygen gas. Now, from our nomenclature work, we know water is H2O, we know hydrogen gas is H2, and oxygen gas is O2, right? Those are part of the Hofbrinkel family. And there you go. H2O, the arrow pointing to the right, turns into H2 plus O2. So that's decomposition. Now, those are the two very simple forms, right, where we have 2 becoming 1 or 1 becoming 2. Now, we can also do some other things. There's other ways to react. And there's 2 other very common ways, okay? The first way, well, really I should say the third way, and the third thing I want you to know is single displacement. So in single displacement reactions, single uncombined elements replace another in a compound. So now we're going to have 2 reactants, so 2 things on the left, and we'll have that arrow. Now we're going to have 2 things on the right. But you'll notice that there's going to be a switch happening. Now this is a bit of a funny example, but hopefully it works. You have this cool dude in the orange shirt here, I think if it was a black and white world, the guy wearing the orange would be the most attractive, right? Okay, so you got this guy, and then you got this couple dancing here, and he becomes Mr. Steal Your Girl and comes in and kicks this guy out, and you'll see after the reaction, he is now dancing with her, and this guy's left on his own all by himself. Okay, so we displace he, the guy in the orange shirt, displaced this guy. Right, so he displaced him so that they're now partnered together. Okay. And that's what we're doing in a displacement. The element is displacing, the metal actually, is displacing the other metal, creating a new compound. So an element reacts with a compound, the element replaces another element from the compound. We'll throw up a whole bunch of letters here. So if we have AB, which is the compound, and we have element Z, well, Z, Z, I guess. Yeah, I think it's Z. Z will come in and kick out A, so that now Z will be with B. Okay, so Z goes to B, and then A is now off on their own, right? So this would be Z, AB, create Z with B, and A on their own. Okay. That's single displacement. There we go. Nice big picture. Now we'll give you a chemical example where we have zinc and we have HCl. Okay, now HCl, there's you could call it hydrogen chloride, but what you could also call it is hydrogen monochloride, because hydrogen is a nonmetal, right? So that's probably the proper name. But the actual name we use for this is hydrochloric acid. So that's actually hydrochloric acid, HCl. What zinc is going to do is going to come in and say, hey, hydrogen, I am happier with chlorine than you are. Chlorine would rather be with me, I think. I think chlorine's more attracted to me because I'm zinc, and you're just some lowly little hydrogen. So zinc's going to come along and say, hey, hydrogen, get out of here. Okay? Now, don't worry about the little numbers at the bottom. We could talk later about why that happens, and that's for another lesson. But just know that the zinc's going to come in, bump up the hydrogen, and then now you have the zinc with chlorine, and you have the hydrogen off on its own, and that's a single displacement. The zinc displaced the hydrogen with the chlorine. And that's it. That's what a single displacement is. Okay. So you can go ahead and read this if you want, but it comes in and bumps out the hydrogen. It displaces it. I think I've said displacement about 30 times, so I think we're good here. Okay, the next one, double displacement. So in this one, we have two compounds, and the metals switch. Okay, they flip. You have two compounds at the start, you got two compounds at the end, but they flip their partners here. And the example we use for this is some funny looking guys wearing hats. So if you notice here, the guy with the round face has a black hat. The guy with the thin face has a white hat. And what happens? Well, they switch their hats. So now we got the round face with the white hat, where before he had the black, and now we got the guy with the long face with the black hat, where he had the white before. So we've just switched hats. We've had two displacements, a double displacement. Okay? So again, if you want, you can copy this down. The generic formula would be we'd have A and B and X and Y. And in this example, you'll see that B and Y switch places, or A and X switch places, depending how you want to look at it. Okay? So A now goes with Y, which we have here, and B now goes with X. Now you could write XB plus AY. There's nothing really wrong with that. You can write it either way you want. And there you go. Double displacement. You have a flip. Okay. Let's go ahead and write that down. And that is the fourth thing that you got to know, a double displacement. So let's take a look at a chemical example. I mean, you could read all the text up here, but really let's look down here at the formula here. So I have silver nitrate, so silver with a little nitrate group, so that NO3 group, okay, silver, and I have sodium chloride, so table salt. So what's going to happen here is the silver is going to say, hey, chlorine, I want to play with you now. And the silver is going to go and bump the sodium out. Well, sodium's not going to go and hang out on their own. They're going to be like, well, hey, nitrate, why don't I come and play with you instead? And so they just flipped friends. So now I'm going to have the silver with the chlorine, like so silver chloride, and then I'll have the sodium going with the nitrate, so sodium nitrate. And that is a double displacement. They both flip partners. And it looks like so. And again, the guys in the funny hats. Well, that's all about I have for you for reactions. It's a pretty simple idea. You have the single displacement, where you have one flipping of partners, you got the double displacement, you have the two flipping of partners, okay? And then you have the synthesis, where you're going from two things to one, and then the decomp, which is going from one thing to two. Hopefully this makes sense, and if you have questions, feel free to ask.